I'm Archie Jacobs with Manufacturing Automation.
And I'm Ron Buford of the PLC Boot Camp.
Ron is a very effective trainer with a different approach that will straighten out a lot of misconceptions about the PLC, not only for beginners, but for those with many years of experience. Ron is going to give us a quick demonstration of the differences between his PLC Boot Camp approach and other training methods.
Well, we've got a long way to go and a short time to get there, so let's get started.
These videos are just a quick preview of the type of material you'll cover in one of our PLC boot camps and of how different our classes are from any other training approach. Don't expect to sit back and listen to long lectures, and we never use PowerPoint slideshows. Instead, we've built our entire hands-on training approach around a problem-solution format. Basically, we set up one realistic problem after another and then coach you through a systematic step-by-step process of finding the solutions. For our first video lesson, we'll use this simple little light box for a quick warm-up exercise. Even if you're beyond the beginner stage, stay tuned for just a few minutes. This uncomplicated little box has bewildered quite a few top guns over the years. Let's see how well you can do against it. If you want to try our first sample problem at home, a micrologic system will work just fine. Depending on which boot camp class you sign up for, we'll probably be using either an Allen Bradley SLC 504 or an Allen Bradley PLC 5 system to control the light box. And yes, we do have boot camp classes for the ControlLogix platform too. The red X is just to remind you that those processors use a different scan sequence, so some of the material in these videos doesn't quite fit those types of systems. We may cover ControlLogix in a future series of videos. And now here's a simple warm-up exercise for the light box. First, here's how many people try to explain the operation of this little program. A warning. What you're about to see does not follow our boot camp approach, and it is not correct. But unfortunately, this is the way a lot of experienced technicians think PLCs operate. We'll identify and correct the mistakes and misconceptions throughout this series of videos. We'll start with switch A in the on position. Notice that both lamps are on. Many people explain this result by pointing out that the contacts for switch A are called examine if closed or examine on instructions. Many people believe that each contact in the program examines switch A in the field to see if the switch is closed or on. Since the switch is closed in this example, the contacts in the program change state and become true. The PLC processor marks them green on the screen to indicate rung continuity and allows power to flow from left to right through the rungs. Many people say that as the power flows to the right, it reaches the outputs of our program and makes them active, as indicated by the green displays on the screen. These parts of the program are called output energize instructions. Many people think that these work like relay coils, and since they're active in this example, they energize the outputs in the field, which turns on lamp E and lamp F. Now let's turn switch A off, and now the question becomes, what made the lamps go off? To answer that, many people go back to the contacts again. Many people explain that now when these contacts examine switch A to see if it's closed, the conditions are going to come up false. That's because the switch is off this time around. Notice that the contacts aren't green anymore, which means that the power signal will not be able to flow through the rungs. Many people use the term inactive to describe the outputs when they're not being powered, and they say that you can tell that these coils are inactive because they're not being shown in green. Many people say that since our relay coils are now inactive, naturally they can't energize the outputs in the field, and that's why lamp E and lamp F both turn off. And so now we're through with our little warm-up program. Now let's crank it up a notch. Keep your eye on this area right here. We're not going to make any changes to the two rungs we've already checked out, but we are going to slide a new rung right in between them. If you're like 99% of our students, you've already been through someone else's PLC training, and the explanation that we ran through a few seconds ago was probably very similar, or sometimes word for word, to what you've already been taught. And let's be honest, those mistaken explanations will work okay, but only as long as you stay at the beginner level. Once you start working in the real world, you'll find a lot of situations where the theory you learned doesn't agree with the reality of your problems. This next little rung we're building is designed to jumpstart you all the way through the beginner level. Notice it's not going to be a complicated rung, just the same basic construction that we've been using all along. And for our input, we'll use switch B on our light box. And now for the output, let's use switch A. Now keep in mind that we're not saying that this is a good way to write a program, and you may never run into something like this ever again. But this little curveball can teach you a lot about how PLCs really operate under the hood. All switches are off, both lamps are off, and now the stage is set. And the question now becomes, what's going to happen to our two lamps the next time we turn on switch A? First, let's see how many people would approach this problem. And once again, the explanation that you're about to hear is based on what many other PLC training courses teach. This is not the boot camp approach. Many people would tackle that new middle rung first, just to get it out of the way. Notice that switch B is off. Many people say that when the input contacts on the middle rung examine switch B, the processor will find the switch in the field to be open or off. That means that there won't be continuity through this rung, and so no power will flow downstream. Many people think that no power means the rung output will be disabled, so it won't be able to affect or control switch A one way or the other. Besides, many people will tell you, there's no way for an output coil in the program to affect an input device like switch A located out in the field. This isn't a special remote control switch. There's no motor, no coil, no nothing out there for the PLC to energize. When you look at it that way, it's obvious why many people think that this bogus rung will have no effect on the operation of the light box. Suppose that we leave switch B turned off and turn switch A on. Many people would now get back to familiar territory, these two contacts for switch A. Many people explain that both of these contacts will still examine switch A to see if it's closed or on, and it is. So both of these instructions should turn green and change state to a true condition, and give us rung continuity. This should let power flow through these two rungs, just like before. Many people would now say that each of these two output coils will have power flowing in, and each will remain active and enabled as long as switch A stays on, and both should turn green on the screen. Many people explain that the two active coils will still do their output energize jobs and energize the output devices in the field. Based on this, many people expect lamp E and lamp F to both come on when we turn on switch A. But just to double check, many people believe that the contacts in the program will examine switch A to see if it's on. The contacts will be true and allow power to flow to the output coils. Each coil will be active or enabled and energize its output. So, final answer, lamp E and lamp F will both be on, or at least that's what many people think, especially since they saw our two original rungs working perfectly before and realize that we haven't made any changes to either one of them. They worked before, they should work now. We'll give you a chance to pause the video now if you don't want the answer just yet. One of the reasons that our PLC bootcamp approach is so effective is that we don't use the old familiar switches and coils explanations. Instead, the real-world material that you'll learn in our classes will take you far beyond the beginner level. And here's what really happens when we turn on switch A. Lamp E comes on, but lamp F stays off. That was totally predictable, and we'll show you exactly why it happens in this series of videos. Before we take a look at the programming screen, remember that we're using a PLC 5 and serial port communications for our example. And if you run this same experiment with a Micrologix or SLC 500 system, the real-world lamps will work exactly the same way, but you'll see a different pattern of green on the screen. We'll put the two systems side by side to make it easier to compare. Pick the left side if you normally work with a PLC 5, or the right side for a SLC 500 or a Micrologix system. On the light box, switch B is off and switch A has just been turned on. And the reality here is that lamp E is on, but lamp F is off, regardless of which PLC system you use. And here are just some of the misconceptions involved in this little exercise. Many people insist that this type of instruction examines a switch to see if it's on. If it worked that way, then lamp F would be on, because switch A is definitely on out in the field. Many people say that when this type of instruction is enabled, then it energizes an output. Well, this one is disabled by switch B, but it's still affecting the program through an input, switch A. Many people insist that green on the screen means true or active and indicates power flow. The instruction at the top is true, but its twin at the bottom is false. Obviously, the green on the screen can't always be trusted. Many people insist that you can get more reliable information by looking directly at the bit tables instead of at the ladder display. Well, here they are. So now the big question, is there a way to make sense of all this? Yes, there is, and we'll give you a sample of the systematic step-by-step approach that we teach in our PLC bootcamp classes throughout the rest of these preview videos. We're going to go a lot deeper than the green on the screen and the switches and relay coils explanations that you've probably heard before.